Good evening, students. Now we will solve some problems using Heisler charts. Problem number 1, I will read the problem number 1. Iron plate with K equal to 60 watt per meter Kelvin, Cp equal to 0.46 kg kilojoule per kg Kelvin, rho equal to 7850, alpha is given of 50 mm. Thickness is initially at 225 degrees centigrade. Suddenly both the surfaces are exposed to an ambient temperature of 25 degrees centigrade with a heat transfer coefficient of 500 watt per meter square Kelvin. Calculate. He is asking center temperature after 1 minute. Second, the temperature at a depth of 1 centimeter from the surface at that time. Energy removed from the plate per square meter during this time. The time is given as 1 minute. Here note that he has given in addition to the alpha is given. Then characteristic length for a slab is 2L by 2 is L. It is 0.025 meters. Bayard number is HLC by K is equal to 500 into 0.025 by 60. It is 0.2083 is equal to 0.21 is greater than 0.1. Hence lump system analysis is not applicable as Bayard number is more than 0.1. Then find out the Fourier number. Fourier number as I have defined alpha t by LC square. Time is 1 minute into 60 seconds. It is 60 seconds. It gives 1.536, and using the graph from Heisler charts for Fourier number equal to 1.536 and Bi equal to 0.1 or 1 by Bi equal to 4.46 K by HL, that is, we will find out the Tc minus T infinity by Ti minus T infinity is equal to 0.76, which gives the center line temperature of the slab as 177 degrees centigrade. Now he is asking the temperature at a distance of 1 centimeter from the surface. Then distance from the center is 2.5 minus 1 by 2.5. It is the temperature from the center is 2.5 minus 1 is 1.5, and x by L is 1.5 divided by 2.5 is 0.6. For Bi equal to 0.21 and x by L equal to 0.6, from chart we will get Tx by L minus T infinity divided by Tc minus T infinity equal to 0.95. We are getting the temperature at a distance of 1 centimeter from the surface as a function of center temperature Tc. It gives 169.4 degrees centigrade. Also find out energy removed from the slab during this period, that is 1 minute. Fourier into Bi square, find out Fourier into Fo into Bi square. Then and Pi is already you have found out 0.21. Again from the chart, Q by Qi equal to 0.22. What is Q by Qi? Qi is the initial rate of heat transfer, instantaneous rate of heat transfer at time t equal to 0. It gives rho into rho volume. Volume is 2L into A, Cp into Ti minus T infinity. This is the Qi. Then you will find out the heat transferred from the plate per square meter during 1 minute as 7.944 megajoules. Now I'll go to the second problem. A metallic sphere of radius 10 mm is initially at a uniform temperature of 400 degrees centigrade. It is first heat treated by first cooling it in air with H equal to 10 watt per meter square Kelvin at 20 degrees centigrade until the central temperature reaches 335 degrees centigrade. Then it is quenched with water bath at 20 degrees centigrade with H equal to 6000 watt per meter square Kelvin until the center of the sphere cools from 335 to 50 degrees centigrade. Compute the time required for cooling in both air and water for the following physical properties of the sphere. Here given the metallic sphere of radius is given. Here the cooling is done in 2 stages from 400 to 335 degrees centigrade. Cooling is done in air from 335 degrees centigrade to 50 degrees centigrade. It's cooled in water. For the first case of cooling in air, he has given H value as 10 watt per meter square Kelvin. For cooling in air, again you find out the Bayard number. You know the LC for the sphere as R0 by 3, which gives 0.001667. It is less than 0.1. Hence we can use the lumped analysis here as it is less than 0.1. Using the lumped analysis for the cooling in air and using H equal to 10, and time is, we find out the time required for the cooling of the center of the sphere from 400 to 335 degree centigrade as 188 seconds. The second part is, it is cooled in water and cooling is done from 335 to 50 degrees centigrade. Cooling is done from 335 to 50 degree, 35 to 50 degrees centigrade, correct. Then for cooling in water, again you find out the Biot number. It becomes, H is 6000, therefore it becomes 1, it is more than 0.1, hence we have to apply the lumped heat capacity method cannot be applied using the Heisler charts. So center temperature is given as 50 degrees centigrade. We know the center temperature, we know the initial temperature as 335. You will find out T0 minus T infinity by Ti minus T infinity as 0.095 and HR0 by K is 3. So then from the using the chart, you find out the Fourier number and is equal to 0.5. T equal to 0.5 into R0 square by alpha, you will get the 7.5 seconds. This is the time required for the center of the sphere to cooling the center of the sphere from 335 to 50 degree centigrade is 7.5 seconds. Note that here we have calculated HRU, just for referring the chart, you are taken HR0 by K, not the HR0 by 3K. It is not, it is, you have to refer which chart you are referring according to the parameters given in the chart. You have to calculate the values. It is HR, if the in the design, in the data handbook, if it is given the HR0 by K, calculate HR0 by K only and refer the charts. Then he is asking surface temperature. Surface temperature means R by R0 equal to 1. Then we know HR0 by K equal to 3, again by using the Heisler charts. So find out the temperature at its surface temperature of the at the end of the quenching in water. It is comes to be 30 degrees centigrade. This is how to solve the problem. Now I will go to the third problem, which is a cylinder. Third problem is a long aluminum cylinder 5 centimeter in diameter and initially at 200 degrees centigrade is suddenly exposed to a convection environment at 70 degrees centigrade with heat transfer coefficient of 525 watt per meter square Kelvin. Calculate the temperature at the radius of 6, here directly given the radius, at the radius of 6, radius of 1.25 centimeter 1 minute after the cylinder is exposed to environment. Take the physical properties of aluminum as rho, Cp, K are given. Now again you find out HR0 by K is as 0.0625 and 1 by Pi, and Fourier number is Fo equal to alpha T by R0 square. We will find out dimensional center line temperature from Heisler chart as T0 minus T infinity by Ti minus T infinity equal to 0.35, and we will get the center line temperature as 115.5 degrees centigrade. Also he has given, he is asking the temperature at a radius of 1.25 centimeter. It then means 1 R by R0 equal to 1.25 centimeter divided by 2.5 centimeter gives 0.5, and for that 1 by Bi equal to 16. From chart you find out the temperature at a distance of 1.25 centimeter from the radius. So it gives 114.59. So since you see alternatively, since we can find Biot number is less than 0.1, it is Biot number is 0.0625, it is less than 0.1. We can solve this problem also by using the lumped analysis. So it is solved also by lumped analysis. We will get the center line temperature after using the lumped analysis as 116 degrees centigrade. So you note that center line temperature obtained is 116 degrees centigrade by using lumped analysis, whereas it is 115.5 degrees centigrade by using the Heisler charts. Both are very close to each other. We have got this almost the same answer. This is because Biot number is very less than 0.1. Both the answers will match. So then also you compare the temperatures. Here temperature at the center of the cylinder is 115.5 and temperature at a radius of 1.25 centimeter is 114.59. So it is almost, we are getting the center line temperature and the temperature at a radius of 1.5 centimeter almost same 114.59 and 115.5. They are close to each other. That means temperature is uniform throughout the cylinder. Okay, and hence we are able to also apply the lumped analysis. Now I will go to the problem number 4. A solid cylinder to 20 centimeter diameter is initially heated to 980 degrees centigrade. Is then quenched in an oil bath at 80 degrees centigrade with convection coefficient of 568 watt per meter square Kelvin. Calculate the time required for the cylinder center to reach a temperature of 260 degrees centigrade. Again the same procedure. He has given center line temperature of the cylinder as 260. Initial temperature of the cylinder is 980. So find out the dimensionless center line temperature ratio as theta 0 by theta I equal to T0 minus T infinity divided by Ti minus T infinity equal to 260 minus 38 divided by 980 minus 38 equal to 0.235. So then HR0 by K equal to 3.55 or K by HR0 equal to 0.2817. Using the graph chart, you are able to find out the time. Fourier number equal to 0.5. We will get it from chart. Fourier number equal to 0.5 to we will find out the time required for the center line temperature to reach to 260 degrees centigrade is 1182 seconds. Now the last problem in this, an iron sphere, problem number 5, iron sphere of diameter 5 centimeter is initially at a uniform temperature of 225 degrees centigrade. It is suddenly exposed to ambient at 25 degrees centigrade with convection coefficient of 500 watt per meter square Kelvin. Calculate the center temperature 2 minutes after the start of exposure. Calculate the temperature at a depth of 1 centimeter from the surface after 2 minutes of exposure. Third, calculate the energy removed from the sphere during that period. Thermal physical properties of iron plate are also given. So sphere also given. For the iron sphere, the properties are given. So find out for the sphere. He is asking the position temperature also at a depth of 1 centimeter. So directly we find out according to the graph HR0 by K is found out K by HR0, then Fourier number alpha T by R0 square. Then from use the Heisler charts, find out the center line temperature ratio, that is T0 minus T infinity divided by Ti minus T infinity equal to 0.18, which gives the center line temperature as 65 degrees centigrade. Then temperature at a depth of second bit B to temperature at a depth of 1 centimeter from the surface, that is from 1 centimeter from the surface means R equal to R0 minus depth. So it is 25 minus 10 is 15 mm. R by R0 is equal to 0.6, 15 by 25, 0.6. From Heisler charts, referring the charts, 1 by Bi equal to 4.8 and R by R0 equal to 0.6. Temperature ratio T minus T0 by T0 minus T infinity equal to 0.95. We are getting the temperature at the required location as 59.2 degrees centigrade. Then heat loss from the sphere during the 2 minute exposure also we can find out by using the Bi square Fourier number and the Biot number. We will get Q by Qi equal to 0.8. Then where Qi is the initial rate of heat transfer, that is rho Vc Ti minus T infinity. This T initial temperature is 225 minus 25, which gives 47.268, and the heat transferred will get 0.8 times the Qi during 2 minutes is 37.814 kilojoules. So thus some of the problems I have solved by Heisler charts, 5 problems. Whatever may be the problems, you just follow the same procedure, find out whatever the quantities required for the charts, and accordingly you refer the charts and solve the problems. So I have solved all some of the problems on Heisler charts. So please go through them. So if any doubts or clarifications are there, please contact me. Thank you.